All right, everybody. A little different video today. This is the happy homesteader in me. Turned this heater system on about 2 weeks ago and fired up. Worked just fine. Checking it out for winter. Went to fire it up yesterday because they're calling for 30-degree weather, and sure enough, it's not working. So checking this thing out, I went to, it was in lockout. Basically, that green light was blinking every half a second. It was in lockout. It had tried to turn on 3 times and then locked itself out, but basically figured out the problem. But anybody out there that's having issues with their heater system, this could be one of many issues, but I figured I'd go ahead and show this because it's kind of important. Haven't seen anything about this on YouTube or online, so figured I'd go ahead and shoot this. But I'm gonna go ahead and turn this thing on and show you what it's doing. Just flipping the power switch. It's gonna try to kick on, and it's humming. Not a whole lot happening, you just hear it humming. And it's gonna go into lockout. The first fault. Not doing nothing. Not doing nothing. And then it went into lockout. So, went through this a few times. I figured I'd try to bleed the oil and all that, but then I realized I heard it wasn't making the right noise that it normally does. So, in deduction, being a mechanic, got to be an HVAC mechanic when you're an actual auto mechanic too, so you might as well figure this shit out, I guess. But I do all my own work. It's a blessing and a curse in the same token. But what I found was, what I'm going to do is I'm going to hit the button. Open the igniter up. Watch the blower wheel. When it goes to start, the motor should turn the blower wheel and the pump. Now it's not letting me, it's realizing that this isn't, see that? But if I just spin this blower wheel, put it back on, oh, it went into timeout. So we'll do it again. We got 3 tries to do this. I'm gonna do it. Okay, at this point I have it reset. The light's not on. I'm gonna turn the power on, and it's gonna try to start, but that motor's not gonna turn. And it's gonna go into lockout unless I take my finger and turn the blower wheel. So I'm gonna go ahead and turn the power on. Wait for the hum. It's going to try to start. Get that blower wheel going. And then the flame will come on. And the whole reason it was going into lockout was because that motor wasn't starting. So there's a couple reasons. Either the motor bad itself, or I'm very confident that the capacitor on the motor is bad. But I couldn't just buy the capacitor. That's kind of outdated and out of stock, all that. So I had to buy the motor. So we're going to go ahead and change this motor out, and everything should be fine. Okay, at this point we got the problem figured out. It's that motor not turning on, spinning the blower wheel and the pump. The controller is recognizing that and throwing it into lockout. So I had to buy the whole pump here, or the motor I should say. And this piece here is the motor starter. It's the capacitor. The one that's on this thing is a lot different. You see it over there, it's a little square box. I couldn't just buy the capacitor, so I had to get the whole motor. Came with the motor starter or capacitor, whichever you want to call it, and the motor itself. So what happens with these electric motors is you got the electric motor itself, but when it goes to start, it has a high load on it. Instead of free spinning and spinning the pump and the blower wheel, it takes a little bit more effort for the electric motor to start. So it takes this capacitor, which basically you can call it the motor starter. And if that's bad, the motor will try to start, but if it doesn't get that extra juice from the capacitor, it won't spin. And that's what's happening with this thing. When you go to start it, all you hear is a hum. And this is pretty much across the board with all electric motors. Being fortunate, I was able to work in an electric motor shop for about 8 months, and I learned this. Otherwise, I wouldn't know this. But we're going to have to change out this whole motor because it's a redesigned capacitor that's attached to the motor. So we're going to go ahead and change out that motor and get this thing going, because it's going to be down to 28 degrees tonight and it's getting cold. So I got this thing fired up for the last half hour, heated the house. I'm going to go ahead and tear this thing apart, fix this thing, and we'll have heat. Okay, got this thing torn apart. Only was a couple screws. 2 screws holding this control box down, which has all the wiring. And then 2 screws over here. One down there, holds the whole motor in. Which, got the old motor out. All it is 2 wires. Got the new motor, 2 wires. We're gonna have to clip this off because the original one just had wire nuts. And then transfer over this blower wheel over to that one and put this thing back together. And we should be looking pretty good. One thing I didn't mention with this is we got this, this is the oil pump drive coupler. And you got your pump motor, which is driven directly with the blower wheel. And then inside you got those teeth there. It has this coupler that extends all the way through the motor to the pump itself. So definitely can't forget that, but that seems to be an okay shape. I probably should have ordered one, but we're gonna go ahead and put this back together because we need heat tonight. That's not half stripped or anything like that. Not too bad. It'd be all right. Just don't forget that if you go to change one of these motors, that's all. Okay, one of the main points of showing this video is showing the exact problem and what I had to do to fix it, because I couldn't get just the one part. But this is the old motor and this is the old capacitor that basically enabled the motor to start turning once it got power to it. And the reason it didn't begin to turn is because of this one capacitor. I call this the start motor, but it's basically just a motor capacitor that was connected right in there. Now this new motor has the motor itself, and the capacitor, you can't even get to it. It's pretty much sealed in. So when that goes bad, you can't change it. The older style stuff, you actually have a capacitor that you could change. But the reason it was humming, the motor was okay, but it needed that extra juice, which this capacitor was bad and wouldn't enable it to start spinning. So we had to change out the whole motor, which is what we're doing. We got that. But any electric motor, this is a lift motor on an automotive lift. which here we are, getting ready to paint this ElCamino frame. Can't wait. This thing is money. Figured I'd get a little shot in there, but this electric motor here, there's your starter. If it has two, it's got a run capacitor and a start capacitor. This one's got a start capacitor. If this motor, if I went to hit this button and all I heard was a humming in the motor, I can pretty much guarantee that just the capacitor's bad. If I hit that button and I hear nothing, then most likely the motor's gonna be bad. But a lot of times it's just the capacitor. And the reason I know this, and I can equate this to real life stuff, is I came back from vacation one time and our AC unit wasn't working. So I took it upon myself, because I know this, and took the side off the AC unit. The motor, the compressor motor, was humming, but it wasn't turning on. And turns out there was literally a mouse on top of the capacitor, and it fried all the wiring. The mouse was toast. This thing was literally fried down to bones because it got caught up. If you ever put your two fingers across a capacitor that's charged, you get a hell of a shock. But that mouse was having a bad day. But ended up changing the capacitor out, and my AC unit's been working for the last 5 years. So it's pretty amazing. Electric motors, you hear it humming. The motor's probably good. It just needs the capacitor replaced. And that's the instance here, but I couldn't just get the capacitor, so I had to get the whole motor. So we're gonna get ready to change out the blower motor. Got that thing off, that's good. Everything's happy there. Put it on the new one and put this thing back together and see how it works. All right, back at the heater unit. Basically got this flipped up, no big deal. Got the motor and blower motor ready to go back in, and the oil pump drive ready to go back in there, and the two wires ready to connect back in here. It's a mess, but there's only two wires, no big deal. I'm gonna go ahead and put this thing back together, see how it works. Okay, we got everything back together. Got the motor on. Got the start capacitor on the new motor. I didn't install that, but it is what it is. Got the blower wheel connected, ready to fire this thing up. All I'm gonna do is apply power to it and see what happens. Power on. You hear the blower motor, you hear the blower running, and it's turning the oil pump. I'm assuming this thing is going to fire up. Uh-oh. Done deal. And all it was that probably $15 capacitor, but I couldn't get that, so I had to change the whole motor out. Looks good. Everything on. Got heat. Stay warm tonight. But sometimes that's what it takes. Back to the ElCamino. Okay, here we are. We basically started at 56 degrees inside the house, and now we're almost a toasty 68. But the whole point of this is this motor actually wasn't bad. Still spinning. But the capacitor, the start capacitor, was the main culprit. I just couldn't buy that separately. Sometimes, many times, you can buy the capacitor separately for the motor just to get it spinning and everything's happy. But we changed that all out. We got heat in the house. All is happy. We're getting ready to move forward because all this was a bump in the road, a rock you had to step over, whatever you want to call it. But we got it all changed out, and now we're getting ready to move on to the ElCamino. And we got this thing primed with metal prep after the sandblast. If you haven't seen that video, check it out. It's pretty happy. Pretty soon, next few days, we're gonna prime this thing and paint it, and it's gonna be nice and happy. So, thank you guys for watching. This was happy Homesteader Day because we got heat in the house now, and we'll talk to you soon. Take care.